Hi, I am Ziao from NUS High's Math Interest Group, and along with Zuan and Rafael, we'll be presenting the work solutions of SMO Open 2017. I'll be covering questions 1 to 10. Okay, so questions 1 through 5 are more sort of warm-up questions and are simpler. It will take you around 3 minutes per question. Feel free to pause the video and try the question for yourself. In fact, I highly recommend you to do so. Okay, so for this question, you'll realize that in order for s to be an integer in the first place, both of these terms will have to be greater than or equal to 0, otherwise s wouldn't be a real number. Solving the inequality, you have two possible values for x, positive 2 and negative 2. However, x equals to positive 2 doesn't work, because that will result in the denominator being 0. So therefore, the only possible x is negative 2, and we substitute that in the expression to simplify the fraction on the left side of the expression for s, which equals 0. On the right side, you have 3 raised to 2017. The last digit cycle through 3, 9, 7, and 1, and since 2017 is a multiple of 4 plus 1, the last digit of s would be 3, so answer is 3. Next question. Again, pause the video if needed. These two expressions denoted here are actually the binomial expansion formulas, but the terms are replaced by square roots. To break down these massive square roots expressions in the question into single, simpler square roots, we remove a factor of 4 from the product inside the inner square roots, which are the 288 and the 48, and we move it to the outside of the square roots, which is to multiply the whole inner square root by 2, so that expressions will follow the general formula, so like so. So conveniently, you can now express all the terms as either a plus b or a times b. So now you substitute the answers into both formulas and you get this, and simplify it gives you 2 as the answer. So answer is 2. Next question. Again, pause the video if needed. We express each fraction as the difference between two fractions, which all have to be multiplied by a factor of 2 in order to equate to the original fractions. Cancel out opposing terms, so we only have 2 times 1 minus 1 over 2017, which is 2 times 2016 over 2017. Multiplying this by 2017 removes the denominator of 2017, so we have 2 times 2016, which is 4032. Okay, so this one is quite interesting. We usually never have calculus with floor or ceiling functions. So again, pause this video if you need to. When you see the definite integral, you just need to calculate the area under the function, and any method will do. For this one, plotting or visualizing the graph as shown here will make it much easier for us. And to count the area, we can just count the number of 1 by 1 boxes. We see that from x equals to 0 to x equals to 1, there are 0 such boxes, as the line is touching the x-axis. From x equals to 0 to x equals to 2, there is 1 such box. Since 55 is the 10th triangle number, this integral takes the area from x equals to 0 to x equals to 11. So the upper bound a equals 11, so we have answer 11. This question is a lot less straightforward than the ones before. Again, pause this video if you need to. So this question states the third line is the angle bisector of lines L and M. So angular distance to lines L and M from this third line will be the same. The dot product of L and the third line will be equal to that of M and the third line. Taking the dot products of the gradient matrices, we find C equals to 3. The question also stated that lines L and M intersect, hence they lie on the same 2D plane. Equating lines L and M, we find that their point of intersection is at 4, 8, and negative 3. Similarly, equating the third line with M, we find A equals to 7 and B equals to negative 3. The sums of A, B, and C is 7 minus 3 plus 3. So we have the final answer, 7. Next question. Again, pause the video if you need to, although this should most likely be one of the easier questions. Okay, so since 7 is between 4 and 9, the floor function of root 7 is 2. So we substitute a equals to root 7 minus 2 into the expression. We simplify as follows, and we reach a final answer of 7. Question 7. We want to split 2017 into a whole bunch of tiny parts, so that each individual part is all either k or k plus 1. Now pause the video if you need to try out the question for yourself. Okay, so there are two possible cases. All of your tiny parts are k, or some are equal to k, and the rest k plus 1. For the first case, you have two possible ways. 2017 tiny parts of 1 each, or 1 of 2017. For the second case, we have n minus a parts of k, and a parts of k plus 1. Hence you get this equation, and simplifying, we have a equals to 2017 minus nk. A can take n possible values, so there are n minus 2 ways to distribute the terms k plus 1. Summing up with our two ways to partition 2017, or with only equal parts of k, we have n equals to 2017 equal possible ways. Okay, next question. Again, feel free to pause the video if you need to. So we take the line AB and we rotate it by about B by 60 degrees anticlockwise. The projection of A is A prime. We thus have the diagram below. Because lengths A of AB and A prime B are equal and angle ABA prime is 60 degrees, triangle ABA prime is an isosceles triangle with one angle equal to 60 degrees, which makes it an equilateral triangle. So you can deduce that the length of AA prime is also 6, and the angle A prime AB is also 60 degrees. Hence A prime AD is 90 degrees. So you can use Pythagoras theorem on triangle A prime AD. Thus the length of AD is 10 by Pythagoras theorem. Next question. Pause the video now if you need to. So because ABE is isosceles, angle ABC is 30 degrees. Draw a line from A to BC and label the intersection E such that AE is the perpendicular bisector of BC. BE is half of BC, which is 15. AE is BE times tangent 30 degrees, and DE is BE minus BD, which is 15 minus 10, which is 5. By Pythagoras theorem, AD squared equals to D squared plus AE squared, which is 100. So AD is square root of 100, which is 10. To a final answer of 10. Question 10. As always, feel free to pause the video now if you need to. Because AC equals to AB and arc BP equals to arc QC, hence the line BP equals the line QC, we deduce that triangles APQ and ABC are similar. Therefore, PQ is parallel to BC and angle APQ is equal to angle ABC. Using sine rule, we obtain AQ equals to PC. Let angle BAC equals to theta, angle BBC equals to alpha, which is 2 theta, and angle ABC beta, which is 90 minus theta over 2. Sine alpha is sine 2 theta, which is 2 sine theta cosine theta, which is 2 times 2 sine beta cosine beta times 1 minus 2 cosine beta squared. Using sine rule again, since AQ sine alpha equals to BC sine beta, AQ equals this expression over here. Cosine beta is root 3 over 4. So once you cancel the sine beta from that expression over there and substitute in cosine beta equals to root 3 over 4, we have AQ equals to 32. So therefore, final answer 32. Now I'll be passing on my time to Zuan, who will be covering questions 11 to 18.